thrilled to introduce you to Renee Yao from Nvidia, who's probably one of the most plugged-in leaders, I believe, in AI and health, having worked with more than 2,000 healthcare startups across all verticals in health. As I saw some hands, biotech, medical imaging, genomics, drug discovery. Before Nvidia, she was building product bundle solutions and architectures for self-driving cars, telecom, big data industries. And if that's not exciting for you, she's also launched 6 of her own startups across different areas. She graduated from Berkeley, enjoys competitive ballroom dancing, reading, and traveling in her free time. Renee.
Hey guys. By the way, Robin's book is amazing. I read it. The first day I got on a plane, I read it front to back. And I've been working with so many of those startups that she mentioned in there. Nvidia, we don't do wearables, but I enjoy reading that section too. So check it out. Her book is a good one. She knows what's going on. Okay, great. Great to be here, everyone. My name is Renee. I lead global healthcare AI startups at Nvidia. Anyone's asking the question, why is Nvidia here? What do you guys know Nvidia for? Graphics cards and? Gaming, that's right. Why is a gaming company standing here telling you guys about healthcare? So let's take a look. Well, first of all, actually, before I go there, you guys maybe came here because of GPT-3, is that right? Everyone know what that is? Everyone know what generative AI is? It just made New York Times, like this week, as of probably 48 hours ago. So it's becoming mainstream. If you don't know it, in short, it's AI generating content. You might think, okay, that's just another AI capability. But think about it in a healthcare space, in the rare diseases space, if you don't have enough data, AI is actually not that smart. You will need enough data to train AI to get it to become smarter. So one way a lot of people are actually doing that is generating AI generating data for AI to be trained to get smarter. So in that space, in our healthcare space, a lot of challenges that we're seeing, of course, all of you guys know, with private health information that could be re-identifying a patient or non-commercial licensing, getting that data with the academic data sets, to lengthy data collection, 1 to 2 years with IRB review to patient consent, all create so much challenges for many of the startups that are probably nodding here, yep, cannot get data to train my AI algorithm, and that's why generative AI started many years ago. The name probably coined about like last year, but a lot of other names you will hear like in the past is like synthetic data and a lot of different approaches. I think DALL-E and Stable Diffusion really put generative AI as a term on the map. So a lot of the top workloads, categories for generative AI, the top line here is a little bit more mature than the bottom line. We're seeing a lot of 2D image generation in X-ray, text using a model called a Gatortron on EHR medical records to life sciences like Pro-T5, ESM1B for drug discovery. And at the bottom, we hope more innovators in the space will get into that space, so help change our industry. We do think generative AI benefiting the gaming background because we see a lot of media entertainment space started doing that. So healthcare, I know we're 10 years behind, but we can get there too. 30 years behind. Trust Robin on her data. Video generation, like for example, in surgery or 3D volume generation, MRI, CT, or to image analysis and diagnostic, image in and text out. Imagine the use cases that come out of it. I could not find a single image in healthcare doing that just yet. But I know in the media entertainment space, in a lot of other spaces, it's already happening and it's quite sophisticated. So we just need some innovators in the healthcare space to get there. I'm going to share a few research that's out there, mainly from Stanford and a couple other collaborators of ours, and then I'll go into why is Nvidia here, okay? So just to let you guys know, to catch up on what's happening the last 3 years. First of all, this one is published by Stanford, and they put together this surgical scene segmentation using semantic image synthesis with this virtual surgery environment. They couldn't figure out how to do these like photorealistic texture for surgery scenes. A lot of the scenes that you now maybe have some VR companies that's in the room, they look like animated scenes. But how do you make it like photorealistic, right? There's like a new research that's going in on how to make that happen. So they expanded a lot of the training data with virtual patient generated with these like wide range of CT data. So this is a paper, if you are interested, go in depth and look at some of the video. Please be mindful, it's actual surgery. If you faint watching blood, don't click on it. And then another model it's actually doing the vision language foundation model. Foundation model is actually the fundamental thing here for the generative AI approaches for chest X-ray generation. So you can actually get like off-the-shelf software like Dream Booth with Stable Diffusion to actually build this chest X-ray generation model. So another paper that was published last year on this as well. And a lot of these are actually using on GPUs. A pattern is going to start forming very soon. And you can see the data set that they were actually creating here in the radiology space. Another one, more on the tech side, you can see that the transformer-based semantic query for medical report generation, inputting the medical imagings to like output with a radiological report that's actually automatically generated with our computer and AI trained. So it's becoming quite powerful. I think a few people maybe go to RSNA every year around Thanksgiving, a radiology conference. A lot of radiologist impression is automatically being generated using AI these days. So this solution actually, I know a few startups is already deploying technology like this. They've been in this space for the last couple of years. The generative AI term just made it a lot fancier. Another in painting, this is a video that actually you cannot see because it's a PDF, but if you get my slides afterwards, you will see this Mayo Clinic actually did a work here with the synthetic data generation in selected regions. What you will see with an image here is that they will have actually the blue segment. You do this in painting kind of, everyone know how to do in painting using like MacBook. You paint it over here and then you say you want this tumor to appear right here and it will happen. It looks like the real thing. So this was what that this research paper actually go in depth to do. So ChatGPT, anyone tried it? What did you guys ask?
Oh my God, too much. I use like 40 times a day.
Right? Yeah, this is so fun. For those who have not tried it.
Overloaded today.
Yes.
3 minutes wait.
For those who have not tried it, which is a little bit over half of this room, we went into ChatGPT 3 and then we asked them, what are the symptoms of cold? Chatbot come out and then with a lot of text coming out. And then we're asking, okay, how are the symptoms different from the flu? And then a lot of text came out. And then afterwards, it didn't stop, it kept going. Other symptoms of flu, like canning flu, blah, 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 we have to like stop the screenshot right there. And then we asked another question, are these the same symptoms as COVID-19? Boom, it's literally talking like a doctor to us. And then we're like, okay, this is way too much information. Let's get a table together. We're like, okay, can you print out the symptoms for cold, flu, and COVID-19 in a table? Boom, came out again. So this is a potential opportunity for ChatGPT in healthcare. I kept it very PG-13, of course. There's a lot of things out there these days.
Google did that before.
Yes, Google did that before, and then there's a lot of things all of the medical professionals should go try and see what are the answers that you get. It's very much a crowdsourced kind of approach here, and then getting the machine learning to train that, to generate the data. fMRI to image generation was also really cool. This one actually, fMRI can figure out what's going on in the brain. The foundational MRI 3D, 2D scans now can actually be able to generate some of the active regions of the brain during the focus activity. I don't want to lose half of the room here. That's why I'm keeping this like very high level. This is research. We're up to speed now, okay? But just assume we're up to speed. Now, you might ask, what is Nvidia doing in this space? We also are working with King's College London to be able to generate synthetic brain images. So to help diagnose neurological disease based on brain MRI scan. This came out 7 months ago. So you know that this space is actually happening quite a lot of innovation in this space. So 100,000 brains images were generated to help with this research. And lots of information on the slides for your post-show reading. So now that probably give you a little bit sense about like Nvidia is more than just a GPU company or a gaming company. And that's right, because Nvidia, we're actually a full stack company. Besides the GPUs, we also have libraries and platform and application framework in this space. On the right-hand side, you will see gaming, but if you only think Nvidia is about gaming, you're missing a lot of the rest of the things. On here, for people in the back that maybe cannot see, you're seeing like finance, cybersecurity, retail, AI speech, robotics, and self-driving car, quantum computing. We all have a play in that as well.
Renee, can I just interject? So one of the things that Nvidia made happen is three-dimensional image navigation.
Yes.
Right? So we had a company actually in 1995 that started doing this, and they were using the silicon graphics chip. And the chip was not 1995. You may not have been
Our
born
company
then.
was born in 1993, so.
Yeah. So literally for three-dimensional image navigation, the silicon graphics chip was not strong enough to create a continuous loop on the three-dimensional. And when the chip came out on Nvidia, we had to go raise another $30 million, seriously, to actually use the Nvidia chip to make it available on laptops. So there would be no three-dimensional image navigation without what you guys are doing.
I did not pay him, so thank you.
I'll hat off to you.
Great, thank you very much. We're more than that now, not even GPUs in the laptop.
Yeah.
A lot of people that don't know is that we not only have GPU, we acquire Metallox for $7 billion in Israel. We have now a networking solution as well in our DPU solution. And we also will be launching CPU very soon. It's all public information. One other thing that a lot of people don't know is we have IGX actually for the medical industry too. So it's a board that is actually 10-year support with ISO 6061. Don't quote me on a number. And we built it into a board for our OEM partners to be able to help enable a lot of real-time surgery solution or ultrasound or endoscopy in the hospital at the edge. And many other type of a system and server. And then we have a layer of the platform layer of NVIDIA AI Omniverse for the metaverse side of the solution. Her next book is about metaverse, so check that out. She just told me. And then NVIDIA Clara is actually our healthcare application framework. It's all of our application frameworks are domain specific. Some of them are for robotics, some of them are for self-driving car. We have a layer for healthcare as well. Monai is open source. It's not NVIDIA's solution, but we heavily supported this among many of the ecosystem partners like Stanford, King's College London, etc. We open source that for radiology and pathology to be able to better label their data and many, many different use cases like a tumor in a CT scan, for example. Flare, a federated learning approach, keeping the data where it is, train a centralized model and share that weights of the model with all of the facility. So when you guys as a startup trying to get the hospital to get their data out, impossible. Ask the hospital just to keep your data and use federated learning approaches to train a centralized model. So that we also make it out open source for free under NVIDIA Flare. Holoscan is our application framework for real-time streaming solutions like ultrasound, endoscopy, and video surgery solutions. So lots of use cases and free software in there. Parabricks is secondary analysis for genomics. As of November, it's also free for startups to use. So if you are familiar in the genomic space, I know a third of the room here are, primary analysis, almost all of the GPU sequencers, all of the sequencers are NVIDIA GPU powered now. Secondary analysis, we acquired Parabricks a few years ago. Tertiary analysis, we have another open source one called Rapids.ai that is actually for data analytics and visualizing it in a graph format, etc. So if you think genomics, primary, secondary, and tertiary, NVIDIA has a play in it. The last one, BioNeMo, is large language models for chemistry and biology. So many people that know about ChatGPT 3, and it's very kind of similar if you have lots and lots of text, using a language model to be able to understand these text data is a form of, we call it the large language model in the technology space. That's why earlier I was joking when she was asking how many biotech are here. I was like, how about how many tech bios are here? Because a lot of the biology and drug discovery startups are going tech first. And that's because a lot of giants like NVIDIA are going in to build a lot of these large language models to help you gain insights with the sequencers that you got, gene sequencing stuff that you guys are getting out. Looking at like the AGTC is looking just like letters and text, right? And on top of that, you can see that within NVIDIA Healthcare, we're supporting imaging, medical devices, genomics, and drug discovery. I'll pause real quick. This is a busy slide. Any questions? Because the rest will make a lot of sense if this slide makes sense to you as a layer cake slide.
You mentioned keeping the data where it is in the hospital, so that's like a big deal with cybersecurity. And I guess where are you in terms of having that be implemented like at a site?
Cybersecurity in hospital as a
Like,
specific.
So you're saying, like, the data would stay in the facility
Uh-huh.
secure with the model that
Yeah.
you guys would.
A lot of that we actually are pioneering with academic medical centers. So if you read the Nature magazine, I think it's 2 years now. Any Nvidias in the room that can correct me? Is that 2 years now, Vanessa? It's been 2 years now. Exam model. Yeah, exam model, if you look at that EXAM, we actually built a COVID-19 model with the list of the hospital together to predict the oxygen need for patient. So feel free to take a look at that to see the latest advancement. 80 authors published together on that paper. Yeah. Yes.
Has this been integrated with any healthcare software at all?
Yes. And my role is managing 2,000 startups, so lots of innovation in that space. I only have 15 minutes, so I'm not going to be able to go through everything in detail. So I hope to chat with you guys separately after for whatever stuff that you guys are interested in. We are in 10 of the top 10 medical imaging, 8 of the top 10 surgical robotics, 7 of the top 10 US hospital, 9 of the top 10 genomics, and 7 of the top 10 pharma. So if you haven't heard about us, click on our website. We have lots to offer. We are very well known in the imaging space. I work with 600 some AI imaging startup solutions, specifically in radiology and pathology. 2D screening to 3D and 4D diagnosis to 5D treatment, we have a play in every single one of them. Either GPUs are being used for training or embedded into these large CT machines or sidecar for like ultrasound, etc. Because our Nvidia Clara, this end-to-end compute, just even using radiology as an example in the middle that you can see FDA-approved AI software as a medical devices is that bottom line. There's a huge gap in terms of clinical translation to a lot of the AI radiology report that's published out there. So you will see that from the hardware and the software side, we're making tremendous progress to be able to enable a lot of solutions deploying at the edge, in the cloud, or in the data center. A lot of leading medical instruments are actually working with us. So household name that you guys are familiar with, but also smaller startups like Moon Surgical. Anyone went to see their demo this week? They roll it on the truck. Oh, go reach out to them, really fun. I don't remember, but we can send you the details. It's very fun. So now let's shift in gear because I know we have room of medical instruments and genomics. Everyone is familiar with this graph, how the cost of per genome is actually going down and the data is actually increasing. Our ability to sequence DNA has far outpaced our ability to decipher the information it contains. So genomic data science will be a vibrant field of research for many years to come. And I think this is a quote that many professionals in this room can actually relate to. This is a busy slide. It basically tells you all of the innovation that's happened just last year. But a lot more happened prior to that that you may not be paying close attention to. I will only mention one on here. That's the Guinness World Record right here. We actually broke the record with Stanford and Oxford Nanopore on being able to do gene sequencing for rare diseases in less than 7.5 hours. And a lot of you guys also maybe in the genomic space know about, okay, a second one, a very cool one. It's Ultimate Genomics, $100 for whole gene sequencing, $100. That's crazy. And inside of their sequencers, also Nvidia GPUs as well. And with that, because of so much data coming in, and there's so much we still don't understand, right? Generative AI and large language models have actually turned biology into engineering. When AlphaFold came out, it made biology cool again. Right? So a lot of things we start seeing domain-specific large language models coming out. And by 2025, more than 30% of the new drugs and material will be systematically discovered by generative AI techniques up from zero today. So these are trends that we're seeing. The space is lots happening now. And that's why, as of last year, NVIDIA announced NVIDIA BioNeMo service. And all of these, this is in short, large language models for biology and chemistry. Details we can talk to those who are interested, so I don't lose two-thirds of the room. But a lot of logos that you can see at the bottom here, large or small companies, which will lead me to tell you a little bit more about the Inception program for 13,000 startups that are working with Nvidia now. I gave you a sneak peek to my VP and General Manager of Healthcare, Kimberly Powell's talk tomorrow at JPM. She has a major announcement coming out, and I did not include those slides here. So if you find this interesting, please go to that or get the live recording link that you guys can watch later. There's some really interesting news coming out in generative AI. So now I'm gonna shift gear to the Inception program for the startups in this space. So we have more than 12,000 startups cross industry, not just healthcare. We have $90 billion cumulative funding representing 100-some countries. And 2 years ago, our percentage rate was 60%. And in this space, you're seeing startups in AI, deep learning, AR, VR, gaming, networking, graphics, and more. What are we doing with them? We are helping them build by providing a lot of AI support. Any of the stack that any of the developers or technologists wanted to leverage, or maybe you're thinking about going into, don't know how to get started, come talk to us. We can help the startups to get started right away with a lot of the resources here. We'll help them grow by providing go-to-market support, pairing you up with hospitals, large pharmas, or be able to invite you to sit in front of 200 to 300 VCs. That's within our VC alliance. And internally, we also have 2 investment arms that have different priorities as well. Happy to share more if you're raising funding. And the last one, scaling them with a lot of go-to-market and technical guidance. Believe it or not, if you're doing patient monitoring in the hospital, you're trying to run AI algorithm to detect patient fall. Do you know how to run 315 stream of live videos all at once without failing? Yeah, we help solve those problems too. So I have the luxury of working with 2,000 startups. Every day a new startup will be like, Renee, let me tell you, what am I working on? And they representing globally close to evenly distributed in North America, Latin America, APAC, and EMEA. And we're tracking more than 500 FDA and CE mark solutions these days. Because we're talking about generative AI, 2 Inception partners this week put this out there, so just take a look. The first one is Antos. They're actually using generative AI to be able to predict some of the any molecule property with protein ligand binding with 10 to 100x fewer experiment. This is their graph. This is a traditional graph. So you guys should definitely take a look at them. There's very close collaboration between them and also our research team, a very, very stellar team. Another one, variational AI, they actually just filed a patent for 2 potential, for the COVID-19 drugs created by generative AI. So this space, a lot of things gonna happen. Pay close attention. What do we do with the startups? When we find innovative startups or any of the startups that want to join us, we build so many different activities with them. The first column is a lot of the marketing activities. Second column, we treat them as developers. We take you to boot camps, hackathons, invite you to join tech summits. We go to a lot of the healthcare specific conferences and we'll do like startup pitches and competitions and make sure that you're in front of the right investors. And we also build special programs. A lot of our startups actually get free access to supercomputing. Maybe a lot of people know Relation Therapeutic that actually went IPO about 2 years ago in the drug discovery space. They purchased 50 servers from us because they need to train so much AI to find the next drug candidate. With that, we do have select a few very good startups get access to supercomputing like that for free for a period of time when we're running special programs. We have a lot of VCs that come to us actually. We'll host like 300 of them at once to our facility in Santa Clara where our headquarters is. And every year we do one AI for Good project. So I had the fortune of going to Africa last year, was able to bring a lot of the free developer tools there to help increase their radiology and pathology AI solution footprint. Lots of partners. I would love another legal and lawyer partners to join my map because a lot of startups will need your help. So lots of partners. These are a selected few. because startups is only one part. It's very important to have a very vibrant ecosystem across the board. And if you are a VC in the room, we want you guys to join our VC Alliance because you get to actually see all of the startups that wanted to raise funding, and we have special activities developed for you all too. Since I'm running out of time, I will just lead you with the last page of, if you are startups, come talk to me. If not, I would like to talk to you too. But join the Inception program. Thank you.